All right, so 6, 7. We're going to do 2 sections today, 6, 7, and then 6, 8. You're looking for these videos. They're going to be, one is going to be 6, 7, and then one is going to be 6, 8. I'm going to have them separated. So if you need to look back on any of these notes, that will be available to you. So we're going to be looking at inverses. Okay? Inverses are what's going to help us to in the next chapter, chapter 7, which is logarithms. We got it. Inverses help us with a lot of different things. Exponents and logarithms are actually inverses of each other. But we have to figure out how to find the inverse of something before we can say what the inverse of an exponent is to get a logarithm. It's a whole big thing. Okay? So the actual process of finding the inverse of a function, super simple. Okay? So to find the inverse of a relation that is given by an equation x and y, we are just going to switch the x and y and solve the new equation for y. Okay, all of our inverse problems, our main thing first is to switch x and y and then solve for y. If it's an equation, we'll solve for y. If it's a table, we won't solve for anything. It's already done. Okay, so looking at the equation, y'all put your phones on. Thank you. Looking at the equation, I don't see a y, but I do see what? F of x. That is my y. So when I am literally switching x and y, that includes f of x. So literally switching x and y. Okay. Then to get y by itself, just going to subtract 3. And you have one final step. Your original y cannot mean the same thing as your answer that's y. Okay? So they have a different notation that's going to denote the inverse. And since we started with f of x, I'm going to keep it as f of x. But you're just going to put that little -1 there. And that implies the inverse. Okay? The little -1 there means the inverse of the function. Okay? So we can't just say y equals x plus 3 and then get an answer and say y also equals x minus 3. We have to say f of x equals x plus 3, but the inverse of f of x equals x minus 3. They're two totally different things. Okay? What's the domain of my original function? What kind of graph is this? Linear. It's a line. So what's my domain? Absolutely. Negative infinity to positive infinity. Goes on forever, includes every x value that I need it to. Okay? Same thing goes down here. It is also linear. So it's going to be all real numbers. Okay? Go ahead and try number 2. Go ahead and find the inverse of that. so I'm going to go ahead and switch my X and Y. So I'm going to add my 5 and then divide by -2. If I am strictly just asking you to find the inverse, I'm really not going to be picky on how you're going to write your answer, okay? You can leave it that way. But if they are asking you to graph, you would want to go ahead and divide these out. So I would prefer that it switches to this point if you have to graph. But if not, then you can leave it that one step above there, okay? So it really just depends on if you're having to graph or not. Okay? So go to your calculator real quick. And on number 1, I want you to type this in as your Y1, and this is your Y2. Your original is Y1. And then your inverse is Y2. X plus 3 was the original, right? Okay. Okay, that's what your calculator gives you. Your original versus your inverse. What do they look like they reflect over? What do they reflect over? I'm sorry? 1x, is that what you said? Y-axis? No, not necessarily. If it was over the y-axis, I would have a line going this way. Yeah. Y equals x. So let's look at the same graph, but with y equals not mode. With y equals x. Same graph, but with y equals x. Okay. Your inverse of your function is always going to reflect over y equals x. Okay. So if you think about it, if my original function had 0, 3, my inverse is going to have 3, 0. Because I flipped x and y. Okay? That's what we're doing here. We're switching x and y. If my original function has -3, 0, my inverse should have 0, -3. Again, it is reflecting over that y equals x. Okay? So, inverses reflect over y equals x. All right? So, why did we learn? Actually, let's do these two real quick before I go into the next part. Go ahead and switch x and y and solve for y for both of these. Find the inverse of both of these functions. All right, so for the first one, if I switch my x and y and solve for y, how can I get rid of negative 1/3? Multiply by negative 3. And when I do that, I have to make sure I multiply everything by the negative 3. So my inverse of f of x is equal to negative 3x plus 6. Okay. Over here, I switch my x and y. Add my 2. How do I get rid of 1/2? Multiply by 2. So I get 2x plus 4. And how do I get rid of y, or the cubed with the y? Cubed root. Okay. So if I take the cubed root of both sides, do I need the plus or minus with the cubed root? No. Okay. Only with square root, fourth root, and so on. So the inverse of f of x is just the cubed root of 2x plus 4. Okay? Cubed root of 2x plus 4. Any questions on those two? Literally switch x and y, solve for y, change your notation. Those are your main steps here. Okay, so what we learned on Friday, I told you we were going to use today because it's going to help us prove that two functions are inverses of each other. Okay, so what you might come across is you'll have this original equation up here, and then this inverse, and then you have to prove that they're inverses of each other. And the way you do that is by composition of functions, which is what we did on Friday. Okay? So, to determine if two functions are inverses of each other, you're going to do f of g of x and g of f of x. If you get x in the end for both of them, they're inverses. Okay? So that's how you prove if two functions are inverses of each other. You'll do f of g of x and g of f of x. If you get x in the end, they're inverses. Now, in some cases, you might simplify down and they both equal 2 or something. That doesn't mean they're inverses. It has to be x. But even if you simplify and in the end they both equal the same thing, that doesn't mean they're inverses. It has to be equals x. Okay? Because remember, they reflect across what? Y equals x. So I can help you remember. Okay, so let's try an example. So let's look at that first one I just enlarged. So we are going to prove if these two are inverses of each other. Okay? So maybe I'll name this one my red equation and this one my blue equation. If you are still doing color-coded. So I'm going to do f of g of x and g of f of x. So that should be a review from Friday. Go ahead and solve both of those. Bless you. Okay, so if I take my f of x equation, which is 5x minus 6, and I plug my g of x equation in there. The good news is, if one of them doesn't work, the other one you don't even have to do, okay? So I notice here that my 5's cancel, and I end up with x plus 6 minus 6, which gets me x, which is what I wanted. Okay? So then now I do my g equation, which is x plus 6 divided by 5. And I plug my f of x equation in there, which is 5x minus 6. So my 6's cancel. I'm left with 5x over 5, which gets me x. So then, yes, these two functions are inverses of each other. I do f of x, f of g of x, and g of f of x, and I get x in the end for both. They're inverses. Questions on that so far? Okay. Try the other two that are up there. Try to make them a little bit bigger for y'all to see. This is 8x cubed and x to the 1/3. Okay, I didn't give myself enough room on that one slide there. So let's look at the first one. So if I take g of x and I plug it into my f of x equation, more times than not, but it's still possible, if it is something weird like that where things don't just automatically start canceling out, they're not going to be inverses of each other. But it's still possible. I can't remember because I teach both Algebra 2 and Pre-Cal. Can't remember if it showed up in Pre-Cal where it was like, oh, this one's ugly, and then it ended up equaling out to x. So don't assume, but just kind of double check and make sure. But if I did kind of finish this one out, I would distribute that 2 to that numerator up there. So I'd have 6x minus 5, or what's 10, over 3 minus 3, all over 5. But then I would have to get a common denominator. So then I would have 6x minus 10 minus 9 all over 3 all over 5, which would get me 6x minus 19 all over 15. And just looking at that, I'm like, there's no way I can just end up with x by itself, okay? Because the first one didn't get me x, I don't even have to try the second one. So this one would be, no, they are not inverses of each other, okay? Right now, it probably will be a dead giveaway for you, but just to make sure, I would just double check that, okay? Over here, I have 8x raised to the 1/3, so 8, or not 1/3, to the 3rd. Remember my exponent properties, when I have a fraction raised to an exponent, that exponent goes to both pieces. And if I have an exponent raised to an exponent, we multiply. So this becomes 8 times x over 2 cubed, which is 8. So far, so good. I have an x. And then if I go backwards, I plug in 8x cubed raised to the 1/3 over 2. Remember, 1/3 is the same thing as the cubed root. So the cubed root of 8 is 2. And 3 times 1/3 gets me 1, which gets me x. So this one is a yes. They are inverses of each other. Okay? So they both have to equal x, f of g of x and g of f of x. Any questions so far? We're about as awake as my 7 a.m. today. Just about. They were.
I mean, I can be louder if you want.
Louder is. Okay, before I said louder is always better because of mask right now. But then I might regret saying that. Maybe not loudest, just a little bit louder.
Okay.
No, that's up there.
No, that's not.
We gotta bring it down. Woo! Okay. Back in the day, in Algebra 1, we did something to a graph to see if it was a function. What did we do?
Yeah.
But if we had a function, what did we do to see or a graph, what did we do to see if it was a function?
Oh, the line test.
The vertical line test, good. Okay, so back in the day, we would take a graph and we would take our pencil across it, and if it only crossed once, it was a function. Okay, so go ahead and let's graph this real quick. You can use your calculator, even though you know how to do it without one. But go ahead and graph that. Okay, looking at that graph on your calculator, is it a function?
Yes.
Yes. That is what you should see. What's the domain of that?
Infinity.
Thank you. Every single time. Okay. Now I want you to solve for the inverse. Go ahead and find the inverse. Okay, so if I switch X and Y, add my 4, divide by 2, so 1/2 X plus 2. And how do I get rid of a square? Square root. But what do I have to include when I take the square root of both sides? Plus or minus. Now, we are not familiar necessarily plugging in the square root with the plus or minus into our calculator. You can't just plug in a plus or minus. What you can do is put one of them as your y1 and then the negative as your y2. Whoops, not that. So that's my original. It's part of my inverse. Here's the second part of my inverse. Just put that over there. Okay. Is my inverse a function? No, it fails the vertical line test. Okay? So my inverse is not a function. What's my domain here?
-4 to infinity.
-4 to infinity, absolutely. And we haven't really learned the brackets and parentheses. We were just putting, whoops, not line. We were putting x. X is greater than or equal to -4. That was from a couple of chapters ago. Okay? So,
I did that homework.
I'm sorry?
I did that homework the other day.
Oh, good. Hey guys, we're catching up. Woo! We're getting there. What are we down to 7?
No, I did them all, but you didn't. I did all of them.
Oh. I haven't graded them yet.
Yeah, there's like
How dare I not grade
Yeah,
all 7 assignments from the
there's
beginning
4
of
left,
school.
and I turned them in like Friday.
Oh yeah, 'cause I got like all 12 of your messages.
I sent you 2. I sent you like an email and a text.
Right. On the weekend, you multiply by 6.
What? I didn't. I sent 2 messages.
Right. But if they're sent over the weekend, I multiply by 6, so you sent 12.
What?
Jenna, what she's trying to say is that you have clones that also send 2 messages, and so there are more, and she got 12.
No, I'm just saying that
Thanks
because
for-
they were over the
You're welcome.
weekend and I enjoy my weekends, that I exaggerate more. Yeah.
I thought you were saying that like the messages multiplied, like you actually got like 12 messages. that were
No,
like,
I would
"Hi,
then
Jasmine,
turn
I
everything
turned in
off
all
and
my
make
missing
it
work."
crash. Yeah.
She likes the weekend because she doesn't have to deal with us meddling kids. And she would have gotten away with it too.
Would have, but I got 12 messages. Okay, so
That was the
what could we do looking at the original function that would tell me if my inverse is a function or not? Okay, so think about it. What could I do to my original function so that way I would know if my inverse was a function or not? Look at the graphs. What could I do just by looking at the original function that tells me if my inverse is a function? Yeah,
Did you do the same test when
did y'all hear that?
we were going
You can do the same test, but horizontally.
Yeah. Nice, Dylan.
Good job. So if I do what's called the horizontal line test to the original, if it fails the horizontal line test on the original, then it's going to fail the vertical test on the inverse, okay? Because remember, we go back to our graph, they are reflecting that y equals x. So when it flips, okay, so I know that if I did the horizontal line test and this whole graph flips, it's going to fail that vertical line test. Okay, so let's put that in words. So So we can tell the original is a function by the vertical line test. But you can tell if the inverse will be a function by using the horizontal line test. Okay?
The vertical line.
Do it.
It looks like you wrote line.
Line.
Line dead.
What's usually going to be a dead giveaway with the original?
Parabola.
A parabola. Good. If it is a x squared, x to the 4, x to the 6, it's going to look like this. I know I'm going to fail that horizontal line test every single time. Okay? A line, a cubed root, depending on cubed root if it goes in different ways. Okay? Those are a little bit not as dead giveaway. Okay, some of those you'd have to test out. But if it is x squared, x to the 4th, anything of that nature, that's going to be your dead giveaway, that it's going to fail that horizontal line test. Because if you think about it, when you solve for the inverse, you have to get rid of a square. You have to get rid of a 4th power. You have to get rid of a 6th power, which means you had to do the square root, the 4th root, the 6th root, which means you had to put the plus or minus. So we haven't graphed square root graphs yet, which we're about to. Well, if you have the plus and the minus, that means they go like this, and that's going to fail that vertical line test. Okay. Any questions on inverses so far? You want to see the hardest question you'll see on your homework? See? Okay.
I support.
I feel like I'm forcing you, but it's fine.
I thought it was like a rhetorical question. You want to see it, and then you're just going to show us regardless.
No, I wanted my people to talk to me.
Hi, Miss
Your
Chapman.
subjects.
I mean, heaven forbid.
Miss Chapman, how's your day been?
You know, it's been fine. I feel like sometimes I ask questions that don't come back to me, like answers don't come back.
We can answer all.
I can answer every single question you
Thank you. Literally, in 7 a.m., I'm like, hey, how are y'all doing? And they're like,
I ask my friend Sam every day, I'm like, how's your day been? And she always says, it's been a day. And
it's been a day.
It makes me very
Joey's uncle
Yeah.
always says busy. I'm like, what do you do every day?
Okay, hardest question you'll see on your homework. The most asked question the next day after giving this homework. What's the inverse of this table? How do we find it? Yeah, exactly. I'm right there with you. I don't get it, but literally every time I assign this homework and it says find the inverse, someone's like, I don't know what to do here. What do you want me to do? I just want you to switch X and Y. I'm with y'all. Y'all are like, is that a trick question? Every year. Inverse, switch X and Y. I don't know what else to tell you, okay? So, it's crazy to me, but I get that question every year. It's your question number 8 and number 10 on your homework. I don't get it, okay? So inverse is your main thing, switch X and Y. If it's a table, you're done. If it's an equation, you have to solve for Y, okay? And then if we're looking at if it is a function or not, we gotta look at both that vertical and that horizontal line test, okay?
Yeah.
Any questions on 6-7?
No, I don't have one.
Thank you for talking back.
I don't have one either.
That's so great. I don't know what this is like. Okay, let's take a quick break.
Bro,